All right, class. So today we are going to do factoring the difference of squares. In the top of the page, we're going to put Q4. This is quarter 4. And this is going to be page 18. Okay, page 18. The title of this page is Factoring the Difference. I'm going to capitalize difference on this one. Of squares. And I'm not talking about a shape, talking about perfect squares. So when you see a perfect square, okay, how do you factor that? Because it's going to be different from how you factor a trinomial or factor by grouping, and it's a little bit different. So please make sure that you focus, because when you see these perfect squares, when you see these numbers that are perfect squares, you're going to factor them just slightly different. All right, so let's talk about what those perfect squares are. Let's list our perfect squares so we'll know what numbers we're looking for. And we'll go up a few numbers. We won't do all of them, but we'll go up to some, okay? So we got one of the perfect squares. If we say 1 times 1, 1 times 1 is 1. This is a perfect square here, okay? This is a perfect square. Why? Because the square root of 1 is equal to 1. And what that means, when you're finding the square root of a number, you're saying what one number can be multiplied times itself to give you this number under the radical. Since 1 can be multiplied times itself to give you the number under the radical, then 1 is a perfect square. Let's do 2 times 2. 2 times 2 is 4. So 4 is a perfect square. Why is 4 a perfect square? Because the number that can be multiplied times itself to give you 4 is 2. Okay, so 4 is a perfect square. And I can box these so you'll know what number I'm talking about. Okay. 3 times 3. 3 times 3 is 9. 9 is a perfect square. Why is 9 a perfect square? Because the square root of 9 is 3. Okay. 3 times itself will give you the number that's under the radical. 9 is a perfect square. 4 times 4 is what? 16. That's all right. The square root of 16 is okay. The square root of 16 is 4. 16 is a perfect square. 16 is a perfect square. Why? Because the square root of 16 is the whole number 4. Because 4 times itself is going to give you 16. 5 times 5 is what? 25. 25 is a perfect square. Why? Because the square root of 25 is the whole number 5. Okay? 5 times itself is going to give you 25. 6 times 6 is what? 36. 36 is a perfect square. Why? Because the square root of 36 is equal to the whole number 6. So that makes it a perfect square. Questions about perfect squares. Are we okay with perfect squares? Are y'all okay? We need to do some more. Y'all speak up. Forever hold your peace. Okay, so you want to do a couple more. All right. 7 times 7. What's 7 times 7? 49. Good job. This is a perfect square. Why? Because the square root of 49 is equal to 7. 8 times 8 is what? 64. 64 is a perfect square. Why? Because the square root of 64 is the whole number 8. Okay? Anytime the square root of that number is a whole number, okay, then that number is a perfect square. Let's do 2 more. 9 times 9 is what? 81. 81 is a perfect square. Why? Because 9 times 9 is going to give me 81. 10, 100. 100 is a perfect square. Why? Because the square root of 100 is equal to 10. So on and so forth. You can continue to make an infinite number of perfect squares. Okay? All right. Let's keep going. Now that we have that under our belt, I'm going to give you some examples of how to factor difference of squares. Okay, difference is subtracting for the most part. Okay, for the most part, you're going to be subtracting. Um, or the binomial that you're going to factor may have subtraction in it. Okay, so let's look at some examples. Again, on these, I'm going to guide you through how to solve these problems. So the first binomial that we're going to factor is 9x squared minus 1. As always, the very first thing you're going to do is try to see if there is a GCF other than 1. There is no GCF other than 1 between these two terms. So we don't factor by using GCF, okay? We don't factor by grouping because it's not 4 terms here. We're not factoring a trinomial because you don't see 3 terms here. But what you do notice about this is that both of these terms are perfect squares. 1 is a perfect square and 9 is a perfect square. And x squared is also a perfect square because it's x to the second power. And it's an even exponent. Questions, comments, or concerns? All right, so this is how you factor that. You're going to have 2 binomials, and the square root of 9x squared is 3x squared. You're going to put 3x squared in both parentheses so that when you multiply 3x squared times 3x squared, that gives you that 9x squared. Any questions about how I came to that conclusion? Now we have 1. The square root of 1 is 1. So I'm going to put a 1 in each one of these parentheses. However, when I multiply, one of the ones have to be a positive and the other have to be a negative in order to multiply them together and get a negative. So we got plus, minus. Any questions as to why I'm making one a positive and one a negative? Okay, and this is going to be my answer here. Make sure that when you check this, okay, if you were to check it, make sure that when you check, you use distributive property twice. And if some of you, I sent the help video to, and I showed you, and in the video, it might have showed you the full method. It's another way to multiply, but remember, because of time, I don't have the time to teach you the full method. We just did distributive property, okay? So here we do distributive property twice. So that's going to be 3x squared, and all I'm doing is just checking to make sure this is right. 3x squared, okay, times what's in the parentheses, 3x squared minus 1. Wait a minute, plus, minus, okay. And then 1. Oh, I put x squared. I should have just put x, y'all. So sorry. My mistake. It's just x. Because when you multiply 3x times 3x, that gives you the 9x squared. Okay. All right, so now let's check it. Make sure that it's right. When we multiply here, this gives us 9x squared. We multiply this gives us a minus 3x. So now let's do this. When we multiply the positive 1, this gives us a positive 3x. And here when we multiply the 1, that gives us a minus 1. Okay? So now these two terms in the middle are the only two that you can combine together. And when you combine this, it gives you 0. So then since they cancel out and that gives you 0, when you combine them, your answer is then this. So it checks out. You see how it checks out? So these two binomials are factors of that binomial. When you multiply those two binomials together, your answer is going to be this binomial here. Any questions about how we did that? Okay. All right. Anyone still copying? Okay, I'll pause for the calls. Bless you, baby. Okay, so number two, we have 4. Sorry about that. 4n to the second power minus 49. Okay. All right. Again, we look for GCF. There's no GCF for both terms. Okay. So we cannot factor this by GCF because it does not have a greatest common factor. What we notice is that they're both perfect squares. Okay. They're both perfect squares. What's the square root of 4n squared? 2n. Okay. What's the square root of 49? 7. Okay, so we have our two parentheses. We're going to put 2n in each parentheses, and we're going to put 7 in each parentheses. Questions about that? Okay, now we are going, because this is a minus, what signs are you going to put in each of these? Plus and then a minus. Very good, or a negative. Why? Because a positive times a negative is going to give me that negative 49 when I multiply back out. This is going to be my answer. Any questions about how to factor differences of squares? It's difference of squares because both of these are squares and we're using subtraction. Sometimes they do still say difference of squares even when there is a